In this video, we will be graphing sinusoidal functions when all the transformations or most of the transformations are involved. So we're going to start off by recapping the importance of all of the transformations and how they relate to certain properties. So we have the full transformed function as y equals negative a sine x minus d plus c. So as a reminder, if your a value is negative, we have a reflection over the x-axis. So a normal sine function would start at the midline, head upwards to the maximum, and continue on the wave. The minute you have a reflected sine function, it's going to start at the midline, but it's going to head down to the minimum and then continue the wave. So that's the impact of that reflection. Next, looking at the absolute value of a, if the absolute value is greater than 1, then you have a vertical stretch by a factor of that a value. If it's between 0 and 1, you have a vertical compression. And this a value is affecting the amplitude, because the minute you stretch or compress, that distance to the midline is going to get bigger or smaller. Next, inside the bracket, you have the x minus d. Looking at the opposite sign, that is your phase shift. So if it says x minus a number, you're going to the right. If it says x plus a number, you're going to the left. And this phase shift really ends up telling you where the start of the cycle will be. Next, we have the plus c. This is your vertical shift, your up-down. But this vertical shift directly impacts the central axis, or that midline. And if you take your central axis and your amplitude together, that will give you your max and your min. So if you take your central axis and you add your amplitude, you're going to get your maximum. And if you subtract your amplitude, you're going to get your minimum. And your central axis value being whatever that shift is. And now if you put your max and min together, that gives you a good idea of your range. Your domain is infinite. And for the sine functions that we're graphing, our period is 360. And if our period is 360, that means every key point occurs 90 degrees apart. So let's start off with a very full question here, where we're going to take this function f at x. We're going to list the transformations that are being applied to the parent function to get f at x. We're going to state our properties, and then we're going to graph the function. So we have y equals negative 2 sine of x plus 60 degrees plus 1. So the negative tells us we have a reflection over the x-axis. The 2, think about if I multiply something by 2, does it get bigger or smaller? It gets bigger, so it must be a stretch. A vertical stretch by a factor of 2. Then the x plus 60, it says plus 60, but I know it means negative, so we're going to the left. Shift left 60 degrees. And the plus 1, shift up 1 unit. Okay, so how does this relate to our properties? Well, the easiest one for me is this central axis. I always like to put it first. So the central axis should be at y equals 1. And my amplitude is 2. Amplitude is a distance, so I'm not taking the negative into consideration. And now with this amplitude and the central axis, I can get my max and my min. Now I am going to do a visual of this while we're looking at it. So I'm just going to highlight my central axis here at 1. And then if the amplitude is 2, I need to go 2 above. So that makes my maximum at 3. So we're just doing the central axis plus the amplitude. And then I'll go 2 below for my minimum, and that will take us to negative 1. So that would be taking the central axis and subtracting the amplitude, and there we are. And I like to highlight these lines because that gives me a good reference of where my function has to take place. It has to take place between -1 and 3, and those are the 3 lines where all my key points will occur. The phase shift is left 60 degrees. The period is 360 no matter what. Domain -infinity to infinity. And the range from the minimum to the maximum. Now that period of 360 will only be affected if there were to be a horizontal stretch or compression, but that is not part of this course. But just wanted to make a note that for us it's going to be 360, but it is possible for it to change with other types of transformations. All right, so I'm going to graph for this scenario one transformation at a time. Now I have my lines there, and I know that's where my function will end up. But I'm going to start off by graphing the base sine function. Starting at the midline, and every 90 degrees, hopping to create that wave. Now I'm going to stretch and reflect at the same time. So my maximum is at 1. When I stretch it, it will stretch to 2, and when I reflect, it will go down to -2. Likewise, the minimum of -1 will stretch to -2 and reflect up to +2. And the zeros are not changing with a stretch or compression or reflection. So this blue one is -2 sine x. And now I'm going to take this cycle and shift it over left 60, so that's 2 boxes, and then up 1, which is also 2 boxes. So that origin point now starts at -60, 1. And notice it is on the midline, and it's just 60 degrees to the left because of that phase shift. And once I've drawn this, because of that reflection, we're not heading up to the maximum like we normally do, we're heading down to the minimum. So I can either get that point with every 90 degrees hop lines. So 90 degrees is 3 boxes. So 3 boxes later, I would be there. If I had used my shifting, left 60, up 1, and there it is. And I can do for the next, left 60, up 1. Left 60, up 1, and left 60, up 1. I personally, once I have my starting point of the cycle, I just know every 90 degrees I hop my key lines. Okay, there's your full cycle. And I am just going to continue the pattern. First, I'm just going to bold this one so we know this was our original. Okay, 90 degrees later. So 3 boxes later, I should go to my minimum. 3 boxes later, midline, maximum, midline. Connect, put an arrow, and let's go backwards as well, just for 1 point. And there we go. Here's our final function, f at x. So in this example, I did graph it pretty much in terms of transformations. I did the a value in 1 step, I did the shifting in 1 step. And this method is perfectly fine. It works well, it really uses those transformations. In the next example, I'm going to show it to you with properties more, and you can choose whichever method you prefer. So we have y equals negative sine x minus 2. So in terms of the transformations, we have a reflection over the x-axis, and we're just shifting down 2 units. That's all we have here. Our amplitude is 1, because there's an invisible 1 here. The negative doesn't affect us. Our central axis is at -2. So I'm actually just going to put a dotted line at -2. And if our amplitude is 1, my maximum is going to be 1 above, so at -1, and our minimum 1 below, so at -3. Our phase shift, we don't have one. which means our starting point will be on the y-axis because we're not going to the right or left at all. And the period is 360. So we know typically our sine function would begin at the origin, but we're shifting everything down. So our starting point is actually going to be right here. It's going to be on the transformed midline of -2, and I'm not going to the right or left at all because there is no phase shift. I could also think of it as my original point was here, and it shifts down 2, and there's where we ended up. Once I have that point, I just have to think. I know I'm going to jump lines every 90 degrees, but because there's a reflection, instead of jumping up to the maximum, I should be jumping down to the minimum in 90 degrees. And then 90 degrees after that, midline. 90 degrees after that, max. 90 degrees after that, midline again. And there's my first cycle. And again, we're going down because we reflect. And now I'm just going to continue the pattern the rest of the way. So in this case, I didn't even really think about the original base function. Just for the reflecting part, I thought about it and the general shape. I just used the properties. I'm going to do one more with properties just because it has a little bit more in terms of the transformations, and then I'll do one more using transformations. Okay, so we have the 0.5. This is a vertical compression by a factor of 0.5, because when you multiply something by 0.5, you are making it smaller. And then shift left 120 degrees because we're taking the opposite sign, and shift up 1 unit. So our amplitude is 0.5. Our central axis is 1. So here's the central axis. This is going to get a little squishy. Maximum half above, minimum half below. So that puts us at 1.5 for the max, 0.5 for the min. We're going left 120 degrees, and the period is 360. So we know sine starts at the midline. So instead of starting on the x-axis, I'm going to start here somewhere at 1. And I'm going to use this left 120 degrees. So on the midline, instead of being here where there would be no phase shift like the previous example, I'm going to go back to 120 degrees to the left. And this is going to be my starting point right here. You could also think of it as the original starting point was at the origin, and we had to go left 120, up 1. And you still get to the same starting point. And now I know there's no reflection, so we should be heading up to the max. And it takes 90 degrees to get there, so 3 boxes later. 3 later, midline. 3 later, minimum, and midline. And there's one cycle. It's clearly compressed. And now I'm just going to continue the pattern. Once you draw your first cycle, it just becomes more of a drawing class. And there we are. So graphing mainly with your properties knowledge. Okay, let's do one more. And for this one, we will do more of a transformations focus. So let's list them out. The 2.5 is a vertical stretch by a factor of 2.5. We have a shift, take the opposite sign, so right 300 degrees, and shift down 0.5 units. So our amplitude is 2.5, our central axis is the negative 0.5. So here's the central axis. And then I have to go 2.5 above. 1, 2, 2.5 will take me to a maximum of 2 and a minimum of negative 3. Now my phase shift is right 300 degrees, and the period is 360. So I know I'm going to start on my midline because it's sine, but I have to go 300 degrees to the right. So right here, that should be my starting point. Oh, actually, I'm going to do this one with transformations. Never mind. I'm going to draw my base function first. There's my base function, sine x. We need to vertically stretch this by 2.5. So I'm going to change my maximum to 2.5 and my minimum to negative 2.5. The zeros stay. There we are. That's 2.5 sine x. And now I'm just going to do the shifting. So I'm going to take this origin point, go 300 to the right, and 0.5 down. And there it is. And I can take the maximum, move to the right 300, which would be 10 boxes, and then up or down 0.5. That's going to take me there. And then the next one here. And at this point, personally, I'm just using the pattern of every 90 degrees, but you can also just count the boxes with your shifting. And there's the cycle. And now I can continue the pattern. This is going to go up 90 degrees, 90 degrees, following that pattern. There we are. And that's it. So really seeing the connection between properties and transformations is helpful. If you're doing the properties method, label your central axis, use your amplitude for your max mins, think about your starting point with that phase shift, but on the midline, and think carefully about no reflection, go to the maximum, yes reflection, go down to the minimum for your first 90 degrees after the start. If you're using transformations, graph sine x, apply your A value with its reflection, stretch, and or compression, and then shift your key points over. And that's it for graphing.